I'm going to do a couple sample problems from the worksheet that has the title Simple Quadratic Equations. They were very kind to us on the left side and already wrote it as a perfect square. So if we take the square root of both sides, square root and squaring are undo each other, they're inverse operations. So we'll just have x minus 5 on the left. The square root of 9 is 3, and it's also negative 3 because negative 3 times negative 3 is also 9. Then we add 5 to both sides. And we have x equals 5 plus or minus 3. And of course, those are like terms. We can combine them. 5 plus 3 is 8, and 5 minus 3 is 2. I'm going to jump to one about halfway down the page. The first thing I want to do is divide both sides by 6. That's lovely. X plus 7 squared equals 300. But unfortunately, when I go to take the square root of both sides, square root of 300 does not come out even. I can rewrite it as square root of 100 times square root of 3, and I don't know what the square root of 100 is. So I have x plus 7 equals plus or minus 10 square root of 3, and unfortunately, negative 7 is not a like term with 10 square root of 3, or fortunately, depending on your perspective, because now we're done. And this is the very last problem on the original worksheet. If we divide both sides by 27, I have x plus 11 squared equals, well, we know we can reduce that by 9. So I've got 100 over 3. When I go to take the square root of both sides, the left side, of course, is lovely. Square root and squaring are inverse operations. They just undo each other. The square root of 100 is fine, but the square root of 3 will be a problem. Square root of 100 is 10, and somewhere someone decided we should not leave radicals in the denominator. So we should rationalize our denominator. Square root of 3 times square root of 3, of course, is 3, and I've got a 10 square root of 3 left when I simplify all of that. So now my final answer is going to be negative 11 plus or minus 10 square root of 3 over 3.